So there are lots of multiverses, actually, in physics. One of them is called the inflationary multiverse, which is we have a theory, essentially what happened before the Big Bang. If you define the Big Bang really carefully as the time when the universe was very hot and very dense, and as I said, you can't argue with that because we can see it, because we can look out into the sky. Our best theory of how the universe got into that state is that there was a time before that, and it's called inflation. So the idea is the universe was there, in a sense, cold and empty and expanding extremely fast. And that expansion slowed down and stopped. And the energy that was driving that expansion got dumped into space, heated it up, and made all the particles out of which we're made. And that's what we call the Big Bang. So that's textbook. It's a textbook theory called inflation. It made predictions, some of which have been tested. Some incredible predictions, actually, about the way that galaxies are distributed across the sky, because they're not just random. If you look at the galaxies, they're in sort of flows and rivers of galaxies that cross the sky in a pattern called the cosmic web. And inflation predicted that before it was seen, actually, so it's an astonishing idea. That theory has a kind of an extension called eternal inflation, which is that the inflation essentially goes on forever, and it just stops in little patches. So you imagine the fabric of the universe, space-time, stretch, and then it slows down and stops in little patches, and each one of those patches is basically a Big Bang and a universe, of which ours is one. So you end up with this sort of picture of an infinite fractal universe of basically an infinite number of Big Bangs, and that's called the inflationary multiverse. And it answers some neat questions, that, because if you say, why is our universe the way that it is? Why are the laws of nature such that life can exist, for example? Well, the answer might be that all possible combinations of all the laws of nature exist in the inflationary multiverse. So then it's not surprising there are universes that permits things like us to exist, because every possible universe exists in the inflationary multiverse. And that's a well-supported theory. It's a theory. So this is not the same as saying there was a Big Bang, which we know, but it is a theory that in its simplest form has made predictions that have subsequently been verified. And we could go on then. There's the so-called many worlds interpretation of quantum mechanics, which is more kind of Marvel film kind of multiverse. So quantum mechanics, it's a probabilistic theory. So imagine a quantum coin, I call it. And the quantum coin, it doesn't have to be heads or tails. It can be heads and tails. So it can be mixed up. Can be both heads and tails at the same time. You may have heard of Schrödinger's cat, which is a cat in a box, and it's both alive and dead until you observe it or interact with it in some way, and then you find out which one it is. But before you looked at it, or before you interacted with it, it was both.